Next up, we have another way of narrowing the type. It's a pretty straightforward, obvious choice, probably, using a Truthiness Guard to narrow or to eliminate null or undefined or any falsy values as potential options. So if we ever have some type that is, let's say in this case, string or null, or string or undefined or something, we can use a Truthiness Guard, basically a conditional, where we just coerce a value to be truthy or falsy, and use that as a type guard. So we do this all the time just in regular old JavaScript anyway. This isn't some revolutionary concept, but I do want to show in TypeScript is smart enough that it can understand the meaning, or it can understand that you're narrowing the type by checking to see if something is truthy. So as an example, if we use our document.getElementById for something that, IDK, that's the ID, we don't need that hash symbol. It may or may not exist. If we save that to a variable, const L, right? Element may exist. It might be an HTML element, or it could be null. That's what we get back from getElementById. That's the type. It doesn't actually know. It can't look into the future and tell you exactly if it's there or not. But if it is there, we're going to get back an HTML element. Otherwise, we'll get back null. All right. So I can write a very simple truthy check. If L. That's it. Just coerce that thing to be a Boolean. And if it's undefined, if it's null, if it's any other falsy value, this evaluates to false, so this code won't run. But inside of here, now if I access L, TypeScript knows for sure it is not null. All we did was check to see if it was falsy or truthy. Well, we checked to see if it was truthy. If it is, inside of here, TypeScript knows, all right, we can rule out null. You have successfully narrowed the type. So we went from this type, null or HTML element, to this type, purely HTML element. And then, of course, if I had the opposite here, in this else, TypeScript knows element, or L, has to be null. So it's doing some conditional analysis, and it's realizing that we've narrowed it here, and then we've got a corresponding else. It's pretty sophisticated. It can figure out types based on our code. It can look at the context. So that's an example, a very simple one, of a Truthiness Guard. And then the one from the slides that you can look at as an example has an explicit union type of string or null for some word parameter. It's called print letters. Let's just try writing this. So it's going to have a word that is a string, or null. Or we could even just do this. Word is optional, and it might be a string. So in here, if we look at word, I'm trying to use an arrow function, so I need my correct syntax. If we look at word, the type is going to be string or undefined. So in here, I can do a little check to see if word is truthy. And now in here, I can write some logic like for let character of word, and I don't run into trouble, right? I can do that. I can iterate over it. However, if I hadn't done this truthy check, now I'm getting an error from TypeScript saying object is possibly undefined. I'm not going to let you iterate over undefined. But if I wrap it in that truthy check, if word exists, then for each character of that word, let's console.log the character. And then otherwise, console.log, you did not pass in. Now, why would we make word optional? I don't know. It's just what we did in this example, although there's many situations where we do want an optional parameter, right? And so something might have a type of number or undefined, string or undefined. Anytime it's optional, that now is a union type because it may not exist. So then we narrow it down inside the function, and one way to do that is using a truthiness check. Instead of checking to see, type of or something, we simply use truthiness, coerce it to a Boolean. If it's truthy, great. Now TypeScript knows for sure it is not undefined. It has to be a string. And then one very important note, down here, what do you think the type of word will be? What does TypeScript think word is? It says string or undefined, and that's because this does not conclusively say word must be a valid string here. All that we're saying is that it's truthy. But there are things that are not truthy, like an empty string is still a string, but it is also falsy. So in this case, TypeScript can't say for sure that down here it's not a string. It could be a string, it's just a falsy string. But up here, it can say, absolutely, I know for sure it is not undefined because undefined is falsy. So I don't know if maybe that's confusing, but it's just it's less black and white or cut and dry compared to something like this right here, where TypeScript knew for sure we're dealing with a string because we said type of string, versus down here it knows for sure it's a number. It's either or. Here it's not as obvious. We're just checking to see if something is truthy or falsy.